Hello, I'm Brian Chen. Today, I will be talking about my project, Automatic Detection of Roadwork and Construction with Deep Learning Model and a Novel Dataset. Recently, there have been many object classification and detection works in the field of computer vision. Some of them focus on general scene classification, some focus on transportation and driving related problems. But there hasn't been too much attention on the construction though. Even though objects like fences and individual walls are included in many previous datasets, these are not out-of-box datasets that could facilitate the identification of construction. Therefore, in this work, we aim to address this issue. First, we introduce a construction dataset by using Google Engine. We use Google Engine because it could be an efficient way to build dataset as we get the label annotation from the query keyword. However, there are some problems such as watermarks, images, and irrelevant images returned from Google, which make us still have to manually check and label the images. Nevertheless, Google Engine still speed up the dataset collection process because we have a really easy way to collect images from the internet. We also build other datasets by collecting images in the real world, which can be served as our testing dataset and to verify the generalization. Specifically, we have 4 datasets from Pittsburgh and 1 dataset from Taipei. We actually mounted cameras on cars in Pittsburgh and have a remote shutter control, which allow us to take picture while driving. And this table over here shows the performance on the 5 dataset. We can see that the performance on the Taipei dataset is relatively low. And we think it is probably because that the environment and appearance of the construction zone in Taipei is differ from the training dataset, which is the Google Engine dataset. And on the right, you can see there's 2 pictures. The one on the above is a picture from Pittsburgh construction zone, and the one below is a picture from the Taipei construction zone. So you can see that the appearance of like the fences is quite different. When working on labeling datasets, we also try to use the train model to automatically annotate the new dataset. But it doesn't work really well in our experiment. We think it is probably because that we don't have enough data to initially train a good model that could do the annotation correctly. And another reason we think is that it's probably just because the training data sets for the models is just have a quite different domain distribution from the data sets being labeled. So the model is not able to actually do the annotation correctly. So we do plan to do some more experiment on this when we have more data sets so that we can verify if this method actually works. And another thing we do is we visualize the feature map of the model to see what the model is actually learning. So here on the left is an input image and one of the feature map of our backbone, which is ResNet 101. And we see that the color is quite important in the feature map, as you can see that the cone, the orange color is pretty obvious in the feature map. And on the right, we also do another experiment to which we only use the grayscale images as the input to the model and see how the model performs compared to using the RGB image. So we see that the grayscale image has a much lower performance compared to the RGB image. It suggests that the models heavily rely on the color information to do the prediction, to identify the construction though. Another thing we do is we try to utilize the segmentation mask as the additional input to the models so that the model has more information about the geometric structure of the construct of the input image. So since we have additional input, the input becomes 6 trainers, and we need to have a way to accommodate these changes of input. So we modify our models in 2 ways, using 2 different ways. The first, we only modify the first layer of the backbone by changing the convolution layer to accept 6 channels input. So that's a really minor modification. And the other architecture we try is we use a 2 branches architecture to where each branches is responsible for extracting the feature for RGB image or the segmentation mask separated. And then we concatenate the embedded feature into one factor and feed into the MLP for final prediction. And on the right, you can see that the 2 branches architecture works much better than the first simple modification architecture. And even though it's much better, this is still lower than the baseline, which is the one without using any segmentation mask. So we think our model is still not good enough to actually extract and utilize the information of the segmentation mask. And we do plan to work on this in the future and potentially develop our own model. And since the segmentation mask is obtained from a pre-trained model that is trained on the ADK20 dataset, which has 150 categories. And this is way too much than what we need. And there's a lot of irrelevant categories in this 150 categories. So we filter out the categories so that only the relevant categories is included in the output mask. Specifically, we try to use all of the relevant categories and the most relevant categories and only the rolled categories in the segmentation mask. And we show the performance over here. We see that when we use filterings and only include the relevant categories, the performance is like 1% higher than the one without using any without using any filters, which is also we use all of the 150 categories. And it suggests that the filtering method is actually working. In future, we plan to revisit the definition of the construction zone for our data set so that the construction zone and images can be more consistent throughout the data set. And we also plan to do more annotation for our construction zone data set, such as the bounding box, maybe the types of the construction, and more. We also want to test our models trained from our data sets on a larger real world images data sets, such as maybe on the bus cameras or on the cameras in the intersection. And we also want to develop our models for better construction zone identification. And this is all I have. Thank you.